Have you ever looked at images of Saturn and wondered about the magnificent rings surrounding this gas giant? How did they form? What mysteries do they hold? These shimmering bands are more than just a cosmic decoration. They're windows into the early days of our solar system. Are you ready to uncover the secrets of Saturn's rings and explore their fascinating role in shaping the cosmos? Join us as we dive into one of the most captivating mysteries of the universe. A cosmic masterpiece, Saturn's stunning rings. Saturn's rings are one of the most breathtaking sights in our solar system, capturing the imagination of astronomers and dreamers alike. These shimmering bands of ice and rock span an incredible width of over 175,000 miles, yet they're surprisingly thin, often no thicker than a few stories of a building. This delicate structure gives them their ethereal beauty and makes them a wonder of cosmic engineering. Each ring is made up of countless particles, ranging in size from tiny grains of dust to massive chunks as large as a small house. These particles are primarily composed of water ice, which reflects sunlight and gives the rings their dazzling appearance. Despite their apparent simplicity, the rings' intricate composition and structure continue to baffle and amaze scientists. The rings are divided into distinct segments labeled alphabetically, including the A, B, and C rings. Each segment has unique characteristics, such as variations in particle density and composition. For example, the Cassini division, a dark gap between the A and B rings, is caused by gravitational interactions with Saturn's moon Mimas, showcasing the complex dance of celestial mechanics. What's even more astonishing is the constant activity within the rings. Collisions, gravitational interactions, and the influence of Saturn's many moons create a dynamic environment where particles are continuously moving, clumping together, and breaking apart. This activity has helped scientists study the principles of planetary formation on a smaller scale, providing insights into how the solar system evolved billions of years ago. Saturn's rings aren't just a visual spectacle, they're a scientific treasure trove. Their unique characteristics and dynamic nature make them an unparalleled laboratory for studying the mysteries of planetary systems and the forces that shape them. The birth of the rings, ancient or recent origins. The origin of Saturn's rings has been a topic of intense debate for decades. Some scientists believe they formed alongside Saturn over 4 billion years ago, while others argue that they're a relatively recent addition to the planet's history. Both theories offer fascinating insights into the workings of our solar system. The ancient origin theory suggests that the rings are remnants of the primordial material that formed Saturn. In this scenario, the rings are made of icy particles that failed to coalesce into a moon, remaining in orbit around the planet instead. This theory aligns with the idea that the rings are as old as Saturn itself, providing a window into the solar system's early days. On the other hand, recent evidence from NASA's Cassini spacecraft points to a younger origin, possibly just a few 100 million years ago. This theory proposes that the rings were formed when a comet or a moon was torn apart by Saturn's gravity, scattering icy debris into orbit. The relatively pristine nature of the rings supports this idea, as they show little evidence of long-term contamination by interplanetary dust. Interestingly, both theories may be partially correct. It's possible that Saturn had older, primordial rings that were later rejuvenated by the addition of fresh material from a disintegrated moon or comet. This would explain the rings' youthful appearance while preserving their connection to Saturn's ancient past. Understanding the rings' origins isn't just about solving a cosmic mystery, it's also about unraveling the history of our solar system. By studying the forces that shaped Saturn's rings, scientists can gain a deeper understanding of the processes that created planets, moons, and other celestial bodies billions of years ago. Cassini's legacy, unlocking the rings' mysteries. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, revolutionized our understanding of the planet and its rings. Equipped with state-of-the-art instruments, Cassini conducted detailed observations that revealed the rings' stunning complexity and dynamic behavior. One of Cassini's most groundbreaking discoveries was the sheer diversity within the rings. High-resolution images showed intricate patterns, including wave-like structures caused by the gravitational pull of Saturn's moons. These waves act as a cosmic fingerprint, providing clues about the moon's orbits and the ring's composition. Cassini also uncovered fascinating details about the ring's mass and age. By studying how the rings scattered radio waves, the spacecraft measured their density and determined that they were surprisingly lightweight. This finding supports the idea that the rings are relatively young, as older rings would have accumulated more debris over time. Another remarkable discovery was the interaction between the rings and Saturn's upper atmosphere. Cassini detected a steady flow of material from the rings into the planet's atmosphere, a process dubbed ring rain. This phenomenon suggests that the rings are slowly disintegrating, and they may disappear entirely in a few 100 million years, a fleeting moment in cosmic terms. Cassini's final mission, the grand finale, involved a daring dive between Saturn and its rings. This maneuver provided unprecedented data on the ring's composition and structure, leaving behind a treasure trove of information for scientists to analyze. The spacecraft's legacy continues to inspire awe and curiosity, highlighting the value of exploration in unlocking the secrets of the cosmos. Shepherd moons, guardians of the rings. Saturn's rings owe much of their stability to a unique group of celestial companions known as shepherd moons. These small moons orbit near or within the rings, using their gravitational influence to shape and maintain the delicate structure of the bands. Each shepherd moon plays a specific role in the ring's dynamics. For instance, the moonpan carves out the Encke gap in the A ring, while Prometheus and Pandora work together to sculpt the edges of the F ring. These moons act as cosmic gardeners, clearing debris and creating striking features within the rings. The interactions between shepherd moons and ring particles are a perfect example of the delicate balance of forces in the universe. As a moon passes near the rings, its gravity pulls on the particles, creating ripples and waves that propagate outward. These interactions prevent the particles from spreading too far apart, ensuring the rings remain well-defined. Shepherd moons also highlight the interconnectedness of Saturn's system. Their influence extends beyond the rings, affecting the orbits of other moons and contributing to the planet's overall gravitational dynamics. This interconnected web of interactions offers a glimpse into the complexity of planetary systems and the forces that govern them. By studying shepherd moons, scientists can gain valuable insights into similar processes in other parts of the universe. These tiny moons serve as natural laboratories, helping us understand how gravitational forces shape celestial structures on both small and large scales. A closer look at composition. What are Saturn's rings made of? Saturn's rings are a celestial wonder composed of billions of particles, yet their makeup is surprisingly straightforward. Most of the material is water ice, giving the rings their brilliant, reflective appearance. These icy particles are mixed with smaller amounts of rocky debris and dust, hinting at a dynamic history of collisions and interactions within Saturn's system. The water ice that dominates the rings reflects sunlight so effectively that it creates the illusion of a solid structure. However, up-close observations from the Cassini spacecraft revealed the true nature of these rings as vast collections of individual particles. These particles range in size from tiny grains of sand to boulders several meters across, creating a complex and ever-changing environment. Spectroscopic analysis has uncovered subtle differences in the composition of each ring segment. For example, the B ring is particularly dense and bright, suggesting a higher concentration of larger ice particles. In contrast, the C ring contains more dust, which gives it a darker appearance. These variations point to a history of different origins and influences for each ring, shaped by Saturn's gravitational forces and its moons. Interestingly, the material in the rings appears to be relatively pure. This purity suggests that the rings have not been significantly contaminated by interplanetary dust over time, lending support to the theory that they are younger than Saturn itself. The bright, pristine ice also raises intriguing questions about their origin. Were they formed from a disintegrated moon, a shattered comet, or even leftover material from Saturn's formation? The composition of Saturn's rings provides a snapshot of the dynamic processes that shape planetary systems. By studying the distribution and properties of their material, scientists can gain valuable insights into the formation and evolution of not only Saturn's rings, but also other cosmic structures throughout the universe. The mysterious heat phenomenon, rings that glow in the dark. Saturn's rings have long been admired for their shimmering beauty, but recent discoveries reveal a hidden, glowing side to them. This phenomenon, first detected during solar occultations observed by the Cassini spacecraft, shows that the rings emit their own heat. This unexpected discovery has sparked new questions about the forces at play within this cosmic masterpiece. The heat emission is particularly pronounced in the dense B ring. Scientists believe this is due to the way particles within the ring interact and generate friction. As the particles collide and rub against each other, they release thermal energy, causing the ring to radiate heat. This process is more intense in regions with a higher density of particles, creating distinct patterns that align with the ring's structure. Another contributing factor to the heat phenomenon is the effect of sunlight. During the day, the ice particles in the rings absorb solar radiation, which they slowly release as heat during the night. This interplay between solar heating and thermal radiation creates a fascinating cycle that reveals the dynamic behavior of the ring particles. What makes this discovery even more intriguing is the possibility that the heat emissions could provide clues about the ring's age and evolution. The patterns of thermal radiation suggest ongoing activity within the rings, indicating that they are not static but rather in a state of constant flux. This dynamic nature could explain why the rings have remained so well defined, despite the forces working to spread their material. The heat phenomenon adds a new layer of complexity to our understanding of Saturn's rings. It's a reminder that even the most familiar celestial objects still hold surprises, challenging us to look deeper and uncover the hidden processes that shape our universe. The faint rings, discovering Saturn's hidden features. While Saturn's main rings often steal the spotlight, the planet is also surrounded by a collection of faint, less visible rings that extend far beyond the familiar A, B, and C rings. These faint rings, including the E and G rings, were discovered using advanced imaging techniques and have revealed a more intricate and expansive ring system than scientists had previously imagined. The E ring is one of the most fascinating of these faint rings. Unlike the dense inner rings, the E ring is composed of microscopic ice particles that are continually replenished by the icy moon Enceladus. Geysers on Enceladus's surface eject water vapor and ice into space, much of which becomes trapped in orbit around Saturn, forming the diffuse E ring. This dynamic relationship showcases the interconnectedness of Saturn's rings and moons. The G ring, another faint ring, is thought to be shaped by the moon Aegeon, which orbits within the ring. Aegeon's surface material is likely eroded by micrometeorite impacts, contributing to the sparse population of particles in the G ring. This highlights how even the faintest rings are influenced by gravitational interactions and the ongoing exchange of material within Saturn's system. Perhaps the most intriguing of all is the discovery of the Phoebe ring, an enormous and extremely faint structure that orbits far beyond Saturn's main ring system. Composed of dark, dusty material, this ring is likely formed from debris ejected by impacts on the irregular moon Phoebe. Despite being invisible to the naked eye, the Phoebe ring is one of the largest structures in the solar system, stretching millions of miles across. These faint rings remind us that Saturn's beauty extends far beyond what we can see. By studying these subtle features, scientists can explore new dimensions of planetary ring systems and uncover connections between moons, rings, and the processes that shape them. Saturn's rings and the solar system's past. Saturn's rings are more than just a stunning feature of the planet. They are a time capsule of the solar system's history. By examining their composition, structure, and behavior, scientists can gain valuable insights into the early days of the solar system and the processes that shaped its evolution. The ring's icy composition suggested a connection to the early solar system when icy bodies were abundant and collisions were more frequent. These collisions may have played a key role in the formation of the rings, shattering moons or comets and scattering their material into orbit around Saturn. The remnants of these ancient events are preserved in the rings, providing a glimpse into a time when the solar system was still taking shape. Gravitational interactions within the rings mirror the forces that govern the motions of planets and moons. By studying the behavior of ring particles and their interactions with Saturn's moons, scientists can model similar processes that occurred during the formation of planetary systems. The rings serve as a miniature version of the early solar system, allowing researchers to test theories and refine our understanding of planetary formation. Saturn's rings also shed light on the life cycle of planetary systems. The ongoing ring rain phenomenon, where material from the rings falls into Saturn's atmosphere, illustrates how planetary systems evolve over time. This process highlights the transient nature of ring systems, suggesting that Saturn's rings may be a temporary feature in the planet's long history. Understanding Saturn's rings helps us appreciate the interconnectedness of the solar system. They are not isolated structures, but rather integral components of a dynamic, evolving system that continues to shape our understanding of the cosmos. By studying Saturn's rings, we not only unlock the secrets of a single planet, but also uncover clues about the origins and destiny of the solar system itself. That wraps up our journey through the secrets of Saturn's rings, a stunning masterpiece of the cosmos. From their mysterious origins to their dynamic interactions with Saturn's moons, these rings remind us of the incredible beauty and complexity of our solar system. If you enjoyed this deep dive, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest explorations. Until next time, keep reaching for the stars.